In this video I'll be showing you how to make a basic game with a growing mechanic using Bolt. You'll be able to move the player around, collect the orbs to make the player grow, and collect the red ones to make the player shrink again. Okay, so in terms of the setup for the scene, we essentially have our player, which is an empty with the cube as a child of the empty. The reason for this is I want the origin of the player to be at the base of it, so that when I scale it up, it essentially scales from that bottom point so that the cube doesn't clip through the plane like it would if we had just scaled it. I also have a basic trail renderer on it, just so we can actually see when the cube is moving around. And then I've got some particles in the scene, just to make it clear when we are actually scaling up and down. In terms of the pickups, they all have gliders set to triggers, and the growing orbs has a tag for the growing orb, and same for the shrinking ones. They also have a tag. And then the last thing is the actual floor plane is just on a different layer called floor, which we'll use to essentially raycast from the screen. So we can start by, I'll just remove this, and then we can create a new flow machine. Okay, and we can call this our player controller, and just put this on our player. There we go. And now let's edit that, and I'll just dock this down here. Okay, cool. So in order to do this, we first want to actually raycast from where we are currently clicking on the screen, so that we can get the point on the screen, raycast into the world, and get a vector 3 position in world space where the character will then move towards. So to do that, we want to do that in an update, because we do want to do that every frame to check for the input. So let's go ahead and add update. There we go. Okay, and we're essentially waiting for the left mouse button, so let's go input .get mouse button. And in this case, we don't want to use up or down, we just want to check every frame whether the player is holding down the button, and then as long as they're holding down the button, we want the player to move. So let's add that. We can leave that at 0 because that's the left mouse button. And then we're going to send this off into a branch. And basically just when this is true, so we are actually holding down the left mouse button, we want to do what's called a screen point to ray, and essentially what that's going to do is take a point on the screen where our mouse is and then shoot that ray out. So you can search for screen point to ray, and we don't want the one with the eye, just the position. And for the camera, we can just search for camera.main. And then for the position, we want our current mouse position. So input.mouse position. There we go. Okay. And then in order to actually use that raycast, let's go and send this to a physics .raycast. And the one we're looking for is ray, max distance, layer mask, and actually hit info as well. So ray, hit info, max distance, and layer mask, that one. And so for the ray, we just drag that in. For the max distance, in this case, because we're going to be scaling our player base, and the camera is actually on that as well, you'll see that the camera will move further and further away from the world, so we need to make sure that our ray is actually long enough to reach the floor. So I think for now I'll set this to 500, because that should be more than enough. And in our layer mask, we can now just search for layer mask literal, or actually just layer mask because we already created it, and then we can just select our floor. That way we can only raycast to the floor, and we don't get any other objects interfering with that ray. So the next thing we want to do is create a variable for that vector 3, so we can save where we're actually clicking in world space. So let's call that our click location, and that's going to be a vector 3. And we can hold down Alt to drag that in so we can set that. I'm going to create a branch out of this, and just make sure that whenever we are actually hitting that floor plane, that we only then set the new location. Okay, and the variable value that we want to set it to is essentially our hit point for this, so we can search for our raycast hit dot point get, and that's what we're going to use for our variable. And this will then give us that vector3 in world space, which we'll use to move our player to. So I'll just create a comment box around this, and this will be our get click world position. Okay, there we go. So the next thing we want to do is actually move the player to that location, and to do that we're going to use fixed update, because we don't want to get any weird stuff happening with dropped frames. We want the physics to just happen normally. So the way we're going to approach this is we're going to look at what the player's current position is. We're going to look at where the target position is, and then get the distance between those 2 points. We then want a sort of threshold so that we know whenever the distance between those 2 points is greater than a specific number, move to that location. So this way we sort of avoid getting any weird calculations happening when the player is very close to that point, and it just makes it a lot easier. So we want to go ahead and add a new float. We can call this our stop distance, and that's going to be a float, and we want to compare what our current position is and compare that to our click location. So let's add a transform dot position, and you can search for vector3 dot distance, and then the other point that we want is our click location, so we can actually drag that in from here. Not the stop distance, the click location. There we go. Okay, so we're comparing our current position with that click location, and then we want to compare that to our stop distance. So we say we can actually, I think we can replace this with just a normal distance vector3. There we go. Then we can just delete that and reassign this. There we go. Okay, so now this will give us a float value, which is what we want in order to compare it to that stop distance. So now we can search for greater or equal, because we want to only do this when our distance between the 2 points is greater than our stop distance. So then we can take that for our B, and then out of the fixed update we can create a branch, use that as the value, and then say if this is true, then we want it to move. So for that we can use a vector3 dot move towards. Vector3 dot move towards. There we go, and this wants our current position, the target position, and essentially how fast we want that to happen. So the current position again is obviously our transform position, so we can just duplicate that. Again, target position is our click location. Then for that speed we can actually create a new variable. We can call that our move speed, and that's going to be a float, and this will control how fast the cube moves from its current position to the new one. So we can drag that in, and we just want to make sure that we multiply this by timed fixed delta time, just because we are working in the fixed update. So we can multiply by time dot fixed delta time. There we go. Okay, and then we'll put that into our move towards. Okay, and now we just actually want to set our position, so we can say transform dot position, we want set, and we want to set it to that vector3 where it's currently at. So as the cube moves, whichever position it's currently at, that's what the new position will be. Okay, so this is then, I'm just going to create a comment box. It's going to move our player to our mouse click position. we go. Okay, and now we can actually test this. We just need to make sure that we actually add values to it. So let's go here and assign the variables. For the stop distance, I think you can mess around with the values for this. There's a bunch of different stuff that you can do, but we want to put it at 0.5 for now, and then our move speed, we can test that at 4. So now what should happen is the player should move around if the user is holding down the left mouse button. So let's see, there we go. As you can see, he sort of follows wherever the mouse is, but the next thing you'll see is if I let go of the mouse, he still keeps on moving for a little bit. And the reason for that is it's still trying to move to that point because it's not its current position, even though we let the mouse up. So we want to put in a check for when the user is letting go of the mouse button, and then just set its current position to the target position. So to do that, we can use another update, and we basically want to get our input.getMouseButtonUp. In this case, again, left mouse button, so 0, and we want to create a branch, and then if that mouse button is released, we want to set our click location to be wherever the player is now. That way it'll stop moving towards that location. So we can hold down Alt and drag that out and set this variable to the current transform.position. There we go. Okay, now if we test this, the cube should stop moving the moment we let go of the left mouse button. So there we go, it's following, and if I let go, it stops moving. Cool. So now that's working, we actually want to get into picking up the different orbs and letting the character actually scale up or down. So let's do that next. Okay. So we want to start by basically checking for when we are triggering or entering the different triggers to only then actually scale the object up and down. But for the scale, we're going to use a similar method to how we did the movement, where we are going to compare its current scale to a target scale and get the distance between those two vector 3's, and then again use a threshold to see whether it's reached that target distance or not, and based on that tell it to scale up or down. Okay, so we can go and add a on trigger enter, because we're using on trigger because both of the two different orbs are just triggers. So on trigger enter, and we want to compare tag and of the object we're colliding with, or triggering at least. And the tag in this case for the first one is going to be grow orb. Again, just make sure that you spell this correctly, it matches yours because this is case sensitive. And we can create a branch and say, if this is true that we're triggering this, do the following. So first we want to destroy whatever we're colliding with, so it seems like we're picking something up. So I'm going to say destroy, and we want to destroy that which we collided with, so I can say collider.gameObject. There we go, and that's what we want to destroy. Cool. Okay, there we go. Then after that, once that is done, we want to actually set our new value for what we want the player to scale to. So we basically want to be able to control how much the player scales up every time with a constant scale number. So in order to do that, I'm going to create a new vector 3 called scale factor. And then whatever value we put in here is how much the character will scale up every time we pick up a new sphere. So let's say we set this to 0.1. Every time we pick something up, the player will get 0.1, in this case 10% bigger to what it was previously. So the next thing we want to do is also create a variable for our target scale, which is the scale that we're going to use to compare what our current scale is against, and then based on that scale the player up or down. So let's create a target scale, and that's going to be a vector 3. And in this case, once we pick this up, we actually want to set our target scale. So we can hold down Alt and drag this out, and then say when we do collide with a growing orb, we want to set our target scale to something new. So we basically want to add this scale factor to whatever our current scale already is. So we want to say transform.local scale get, and we want to add this to our scale factor. There we go. And then basically that's the value that we're going to set the target scale as. And then obviously when we are actually done scaling, we want that scale factor to increase in this case and then decrease with the other orb every time that the character scales up. So that way you sort of keep a certain type of constant scaling. In your case, you might do something different with this because this is going to be not so subtle. You're going to be able to see the player rapidly scale up or down. So depending on your case, you might change this. But in this case, I'm just going to do it like this, where I can say I'm going to set the scale factor to whatever the scale factor was. So just drag that out again. I'm going to multiply that by float. There we go, and I'm going to multiply it by 1.2. So what this means is every time this factor has been modified, it'll take whatever it is at the moment, multiply it by 1.2, and that's going to be the scale factor the next time around that you pick something up. So we want to drag that into our set variable. And then this is going to be all the logic we need to actually pick something up. The next thing we'll do is to actually scale the object using this target scale. So I'm just going to create a comment group around this. And this will be when our grow orb is collected. Cool. While we're busy with this, for the shrinking orb, it's going to be almost the exact same logic, minus a couple changes that we can make. So we can actually do that now while we're busy with this. So we can just duplicate all of this. And what we're going to change is this tag. Instead of grow orb, it's going to be our shrink orb. And then this this add is instead going to be a subtract. So I'm just going to replace that with a subtract. And then just reassign these. There we go. Okay, and then instead of multiplying it by 1.2, we basically just want to divide it. So it's basically doing the exact opposite of what we did for the scaling up. There we go. And this is going to be when we collect our shrink orb. Cool. Okay, so now to get the player to actually scale to that new size, we need to do that in the fixed update. And so what we're going to do is we're going to again compare those two different vector 3s, get the distance between them, compare that to our threshold, and then based on that decide what we're going to do. So in order to do that, we're first going to create that threshold variable. So we can say scale threshold, and that's going to be a float because it's just going to be the distance between them. And then where we're actually scaling, we're going to be lerping the size. What that means is we're basically going to scale it smoothly from the current size to the new one, instead of just making it snap to the new size. That way you get a much smoother feedback when the player is actually picking up the different types of orbs. But for now, let's just add a float called scale speed. Okay, so to start the scaling, we're going to add a fixed update. And basically what we want to do inside this is, again, start with our local scale. get that, and we want to get the distance between that and our target scale. So we can just drag that out. Okay, and then we want to check if actually again, let's just use a different one. This one works better, so let's just use that. And we want to compare that float and see if it's again greater or equal to our scale threshold. And then in this case we're going to again get a branch, and then what this basically says is if our distance between the two of them is greater than our threshold, move them to the new location. So if this is true, we're going to do a vector3.lerp. Go, and our A is going to be our current scale, B is going to be our target scale, and then the T is going to be our scale speed. Okay, for the scale speed we actually want to again multiply that by our time.fixedDeltaTime. Go, and that's what we're going to drag into the T. Cool. And then the last thing, we just want to set our transform scale. So transform.localScale, and we want set, and we wanted to set it to that lerped value. Okay, so I'm going to add comments around that. This is going to scale to new size. Okay. And then one more thing, the last thing to consider is when this game starts, it'll immediately fire this, and the player will look for whatever our target scale is. So if it's by default set to 000, obviously it's going to immediately scale the player down. So we want to make sure that doesn't happen at start. So we're going to add, before everything happens, a start, and we're going to set this target scale. So hold down Alt and drag that in. We want to set this target scale to whatever our current scale is. Transform.localScale. There we go. So what this means is at the start of the game, it'll see that its current target scale is the same as its local scale, and it won't do anything until that target scale changes. Cool. There we go. So now, if we go back into our scene, before we can test it, we just need to add some values. So for our scale factor, again, you can do this in different ways. You can have a float for your scale factor and then just have that feed into the XYZ values. If you want to use it like this, you can have different values based on your axes. So you can have your player scale maybe just in the X and Z direction instead of scaling up, or just have it scale in the Y direction. So there's a bunch of different ways that you can do this. I just want mine to scale up constantly, so I'll put everything at 0.2. The target scale is being set in the code. The scale threshold, we want it to be about 0.1, so it gets pretty close to that destination scale. And then our scale speed, we can test that with 2. And I think now if we test that, the player can move around, pick up the blue orb, the player smoothly scales up. So if we collect a few here, you can see as the player scales up. And then if you collect the red ones, the player scales down. Awesome. And there you can see where the lerp comes in, you can see the player scale smoothly up and not just snap to its new scale. And that does make the whole scaling effect look a lot better. Cool, I think that's that for covering the growing mechanic. In the next video, I'll be covering the same mechanic, but in C#.